Hey, this is Science Sav. Welcome to part 2 of elephant toothpaste. Last time in part 1 of elephant toothpaste, we showed you how to do this at home. And in this video, we're going to show you how to make the most exciting reaction using different percentages of hydrogen peroxide and different amounts of the catalyst, the yeast. Last week, I asked you guys to comment whether you thought adding more hydrogen peroxide or adding more yeast would make the reaction bigger. If you didn't comment last week, go ahead and comment now to see if your hypothesis is correct. So let's go over the ingredients again and the reaction that's happening. So we have our hydrogen peroxide that's turning into water and oxygen via the catalyst, our yeast. So we need hydrogen peroxide, we need yeast, we need containers to put this in for our explosion to come out of, and then we also are going to need warm water to activate the yeast. And then last but not least, we're going to need some food coloring to add some color to our elephant toothpaste. It's also a good idea to have some sort of tray to collect your overflow of elephant toothpaste in. Our reactions this time are going to be bigger than in that first video, so this is more important than ever. Our first experiment is going to be comparing different percentages of hydrogen peroxide at the same volume with the same amount of yeast and soap. And so first we have 12% hydrogen peroxide. This is industrial grade, while this is 3%. So this is what you would find at the local drugstore. The first step is to activate your yeast, and so we added 100 milliliters of warm water to a full packet of yeast, and then you stir. The next step is to add a squirt of soap to the bottoms of our water bottles or containers. After the soap, we add hydrogen peroxide to the bottom of our containers also. And so I want to compare these two in equal volumes. So I'm going to use this little graduated beaker to measure out an exact amount. If you're at home, you can always use a measuring cup you would use for cooking. Clearly it comes out quickly, be careful. And now for the 12%. So we have the 3% in this one and the 12% in this one. Any guess as to which one will have the bigger reaction? Now we're going to add the food coloring. This isn't a part of the reaction, it's just for fun to make our toothpaste fun colors. We added the soap, we added the hydrogen peroxide, we added our food coloring, and now it's time to make the reaction happen with the yeast. So I'm going to pour half of the yeast in here so that I can dump it in at once and we can compare the two reactions. Well, obviously there's quite a difference between our 3% and 12%. The 12% made this awesome big reaction, while the 3% didn't even make it out of the water bottle. So that just shows you how important it is to have a higher amount of your reactant available for the reaction. We're now going to experiment with the different amounts of yeast added to our bottles. So we're going to do a small amount of yeast, a medium amount of yeast, and a larger amount of yeast with the same amount of hydrogen peroxide. Since the last video clearly showed that 12% makes a bigger reaction, we're going to stick with 12% for this one. I'm going to add 25, 50, or 100 milliliters of this yeast concoction we have to test whether or not the quantity of catalyst added matters. Wow, okay. That one came out hot. Literally, there's some heat coming off of this one. So all of these were super fun though. Look at this one. I almost like the slow burn coming out of the lowest amount of yeast. But it was pretty obvious to me that adding more yeast, the catalyst, made the reaction happen super fast on this right-hand side one that's literally burning out of our container. Whereas having less, the reaction still happened, obviously, but it was a little slower and actually enabled the toothpaste to come out in more of a tube-like fashion. We now know that the percentage of hydrogen peroxide matters and the amount of yeast matters in making a really dramatic reaction. We're now going to experiment with the quantity of hydrogen peroxide with the same amount of yeast. We're going to test out different volumes of hydrogen peroxide now. So in this one, we're going to put in 25 milliliters, 50 milliliters, and 150 milliliters with the same amount of yeast in each one. We're now experimenting as to whether or not we can max out our catalyst, the yeast. So there should be, theoretically, some level at which we add so much hydrogen peroxide that the reaction doesn't happen any faster because there isn't enough yeast to react with it. The middle reaction should react more than the lowest reaction, but I'm wondering if the highest amount of hydrogen peroxide will actually max out the yeast and we won't see a difference between the high and the middle. This is a lot of hydrogen peroxide. A little nervous. It's already pretty close to the top. Just as a reminder, we're putting the same amount of yeast in each one. This is definitely interesting. It's a little warm. Well, we obviously have some different reactions occurring here. This one sprouted out nicely, but at a slower rate than this middle one, while this third one is a little bit all over the place. There's a lot of bubbles, a lot of suds, very different than these that sprout out in this nice continuous funnel. This makes me wonder if my guess was correct or not. I don't think we quite maxed out the hydrogen peroxide here, but we obviously had it in a different enough ratio that the reaction itself was different. It looks like our hydrogen peroxide affected the volume of our toothpaste that we made, but not necessarily the speed at which the reaction happened. Whereas our yeast obviously dramatically made a difference in how fast the toothpaste came out of the water bottle. So how can we make our elephant toothpaste even bigger?
Ladies and gentlemen, please take your seats. The show is about to begin.
We've learned that the percentage of hydrogen peroxide matters, the amount of yeast matters, and that the volume of hydrogen peroxide affects the amount of reactant created. But now we want to make a really efficient, dramatic reaction together, and so we need to balance the amount of hydrogen peroxide and yeast. What better way to do this reaction than in a pumpkin? This is going to allow us to put a ton of hydrogen peroxide, a ton of yeast, and it's fun because it's in a pumpkin. I've carved out my pumpkin. Let's recap what we've learned today to try to make this the biggest reaction possible. We now know that having more hydrogen peroxide at a higher percent makes for a bigger reaction. We also know that having more of our catalyst, the yeast, makes for a faster reaction. But we also know that having more yeast without more hydrogen peroxide won't work because that's our reactant. And having too much hydrogen peroxide and not enough yeast doesn't make the reaction very fast because we need enough yeast to make it happen quickly. And so we need to increase these two in proportional amounts to have a really fast, big, dramatic reaction. Also, who's excited about doing this in a pumpkin? Because we're going for a really big one, we're gonna move this outside. We're adding all of our usual reactants. Just a lot of them. Let's add a little more. I really have no idea how big this is going to be. I'm prepared to jump out of the way if I need to. Who knows? Here we go. Okay. All right. Can't even see the pumpkin anymore. Wow. We're gonna do one last experiment now. We're gonna add the soap, and then we're gonna add the hydrogen peroxide, our food coloring, and the yeast, and then we're gonna put the lid on to see if the reaction is strong enough to push it off. I have no idea what's gonna happen. And now the final ingredient. Here we go. Well, that answers that. This is a hot pumpkin, folks. There's some steam coming off of this one. Well, there's no stopping this, folks. Wow. If you're enjoying these videos, make sure to like and subscribe. I'm loving creating this content for you all, and I can't wait to see what comes next. Ooh, it's hot. It's hot, folks.